Okay, so ancient bird mimic. That's the translation of Archaeornithomimus.
Yeah, quite a name, isn't it?
It really is. Kind of makes you wonder, what secrets about the prehistoric world? What's locked up in a dinosaur called that? Especially thinking about, well, the late Cretaceous period.
Oh, absolutely.
Yeah.
That name immediately flags those evolutionary links, doesn't it?
Right.
Between dinosaurs and birds. It puts this creature right in that really interesting time period.
Exactly. So that's our focus for this deep dive, Archaeornithomimus. We've gathered the paleontological research, the notes, the
All the
findings.
science stuff.
Right. And our aim today is just to give you a clear picture of why this particular dinosaur is, well, pretty significant for understanding the past.
Yeah, we'll dig into the publications, track its discovery, how its classification changed as more stuff came to light,
Yeah.
and what the fossils actually tell us. It's a story about science just as much as it is with the dino itself.
Okay, let's do it. Let's rewind. 1923, big expedition, right? American Museum of Natural History going to Inner Mongolia.
That's the one. Led by Ray Chapman Andrews, a famous name.
And Peter Kaizen was on that trip.
He was. And he found, across 3 different quarries, a whole bunch of theropod bones. But they were disarticulated?
Meaning not connected, like scattered pieces.
Exactly. Not like a nice, neat skeleton. More like finding puzzle pieces all jumbled up.
Right, right. So someone had to put them together. That was Charles Whitney Gilmore in, what, 1933?
Yep, 1933. Gilmore looked at these bits and pieces and said, okay, this looks like a new species of Ornithomimus. And he called it Ornithomimus asiaticus.
Makes sense. Found in Asia. But you mentioned puzzle pieces. Were some missing?
Crucially, yes. They didn't find any skull material, no lower jaw either, and that lack of, head stuff, that becomes important later.
I bet. So first classification based on what they had.
Pretty much.
Yeah.
Which is often how it works in paleontology. You work with the evidence available, and sometimes that understanding, well, it changes when new finds pop up.
Okay, so fast forward a bit. 1972, Dale Russell comes along.
Right. Russell takes another look at Ornithomimus asiaticus and decides, you know what? This is different enough. Needs its own genus.
And that's when we get Archaeornithomimus.
That's the moment.
So where did that name come from? Ancient bird mimic. Why ancient?
Well, Russell chose that because at that time, the thinking was that the rocks these fossils came from were actually older than we now know they are. They thought Cenomanian Turonian age.
So like really early for an ornithometid.
Exactly. The ancient part reflected that idea that it was one of the earliest bird mimics they knew of back then.
Interesting. Now, you mentioned Gilmore described it first. Did he pick out like the main fossil, the holotype?
He didn't, actually. Which is a bit unusual, but happens. So it wasn't until much later, 1990, that David Smith and Peter Galton sorted that out.
How did they do that?
In their big, detailed paper redescribing everything, they designated one specific fossil, AMNH 6565. It's actually a foot as the lectotype.
Lectotype, so like a substitute holotype.
Yeah, basically. When the original describer doesn't pick one, later researchers can designate a lectotype to be the official reference point. Keeps things clear for everyone studying it.
Got it. So this foot and the other bones Kaizen found, where exactly did they come from? Which rock formation?
They all came from the Iron-Dabasu Formation. That's in Inner Mongolia.
And the age. Is it still considered as old as Russell thought?
The dating's been refined.
Uh-huh.
We now place the Iron-Dabasu in the Cenomanian age, so around 95.8 million years ago, plus or minus about 6 million years.
Okay, so still pretty old. Cenomanian. Russell wasn't that far off in thinking it was early.
No, his intuition about it being relatively early in the Archaeornithomimus story was pretty good, even if the exact dating shifted a bit.
Now, paleontology always seems to have these confusing side stories.
Yeah.
Let's talk about Archaeornithomimus affinis. That sounds like it should be a close relative.
Ah, yes.
Yeah.
Relaphinus. It's a classic example of how scientific understanding shifts over time. That's quite a journey for these particular bones.
What bones are we talking about?
Just some foot bones. But they were found way, way back in 1888.
Wow, 1888. Where?
In Maryland, actually. Here in North America. From the Arundel Formation, which is early Cretaceous. Much older.
Maryland. Okay. And what did they originally think it was?
Well, the famous Othniel Charles Marsh himself initially identified them as belonging to Allosaurus.
Allosaurus, the big predator. That's nowhere near an ornithomimosaur.
Not even close. Yeah, talk about a first impression that didn't quite stick.
So what happened next with these Maryland foot bones?
Well, things changed. In 1911, Richard Swan Lull looked at them and decided they were a new species of Dryptosaurus, another theropod. He called it Dryptosaurus grandis.
Okay, still not Ornithomimus.
Nope. But then in 1920, Gilmore, remember him from O. Asiaticus?
Yeah.
He re-examined the Maryland fossils, and he thought they looked like Ornithomimus.
Getting closer.
Getting closer.
Yeah.
But there was a problem. Someone had already used the name Ornithomimus grandis, so Gilmore had to give it a new species name, Ornithomimus affinis.
Affinis is meaning like related or similar?
Exactly. So it went from Allosaurus to Dryptosaurus to Ornithomimus affinis. Quite the identity crisis.
And then Russell came along in 72.
And he lumped it into his new genus, calling it Archaeornithomimus affinis.
Okay, so that's how it got the name. But is it still considered Archaeornithomimus?
Not really, no. The current thinking, the consensus, is that A. affinis is what we call a nomen dubium.
A dubious name, meaning?
Meaning the fossils, just those foot bones, remember, are too fragmentary. They don't have enough unique features to confidently say, yes, this belongs to this specific genus or even family.
So they could be anything.
Well, Smith and Galton, back in their 1990 paper, suggested they probably belong to some other small theropod, maybe not even an Ornithomimus at all.
Huh. But I saw a note. Some other researchers think differently, people studying related dinosaurs.
That's right. It's still debated a bit. Some paleontologists working on ornithomimosaurs like Archaeornithomimus from Asia or Archaeornithomimus from here in North America or Prehistoric down in Mexico, they've suggested that maybe, just maybe, affinis is some kind of indeterminate ornithomimosaur.
So the jury's still kind of out on those Maryland bones.
Pretty much. It really shows you how tricky interpreting fragmentary fossils can be. It's that ongoing process of discovery and reevaluation.
Definitely keeps things interesting. Okay, what about the other one? Archaeornithomimus bisectensis. Where did that one come from?
Right. That one's from Uzbekistan, Central Asia. It was named by a paleontologist named Nisov back in 1995.
Uzbekistan. And what formation was that?
The Bisekti Formation. It's Turonian in age, so a bit younger than the Iran-Dabasu.
And what was it based on? More fragments?
Yeah, primarily a juvenile femur, a thigh bone that was the holotype, plus a few other foot bones, metatarsals.
But it sounds like its connection to the main Archaeornithomimus from Inner Mongolia was also questioned pretty quickly.
Oh yeah, very much so. Most research after Nisov's paper either doubted the link or just didn't really mention it as being closely related to Archaeornithomimus asiaticus. There was always this taxonomic cloud hanging over it.
And has that cloud cleared now? What's the status of A. bisectensis today?
It has, actually. Very recently, just this year, 2025, a study by Averianoff and Sues officially moved it out of Archaeornithomimus.
Oh, so where did it go?
They assigned it to a completely new genus, Xerocursor.
Xerocursor. Okay, so that branch has been neatly pruned from the Archaeornithomimus tree.
Exactly. Another case of refining the dinosaur family tree as we learn more.
All right, so let's get back to our main subject then, Archaeornithomimus asiaticus. We've cleared up the naming and the dubious relatives. What did this thing actually look like? How big was it?
Okay, so based on the fossils we have, Archaeornithomimus was what you call a medium-sized ornithomimosaur. We estimate it got to about 3.4 meters long.
So roughly 11 feet?
Yeah, about that. And weight-wise, maybe over 71.5 kilograms, so around 158 pounds.
Okay, so decent size, maybe like a very large ostrich lengthwise, but probably built differently.
A bit heavier, probably, and definitely built for running, but yeah, comparable in length to some of those bigger flightless birds today.
And the name bird mimic obviously suggests birdy features, feathers, beak.
Well, we don't have direct fossil evidence of feathers for Archaeornithomimus itself, but based on its close relatives within the ornithomimosaurs. Yes, the evidence is very strong that it would have been feathered.
What kind of feathers? Fluffy down, flight feathers.
Probably more like the feathers on modern ratites. Ostriches, emus, maybe somewhat shaggy or filamentous. And yes, almost certainly had a keratinous beak like modern birds.
Wow. Feathers and a beak on a dinosaur nearly 96 million years ago. It's still just incredible to picture.
It really is.
What about its legs and feet? Built for speed, you said.
The hind limbs look pretty robust, yeah, suggesting it was a capable runner. But interestingly, its foot structure is what we call non-arctometatarsalien.
Okay, hold on. Arctometatarsalien. Break that down for us.
Right. So in a lot of fast-running theropods, the middle long bone in the foot, the third metatarsal, gets kind of pinched or narrowed at the very top where it meets the ankle bones.
And that helps with running.
Yeah, it's thought to provide extra stability, maybe absorb shock better when running fast. It creates a more tightly packed structure. Archaeornithomimus didn't have that pinched bone, Its third metatarsal was more uniform in width at the top.
Huh. So does that mean it wasn't as fast as some others? Or maybe ran differently?
That's a really good question. It might suggest it wasn't built for the absolute top speeds of some other theropods with the arctometatarsaline condition. Or perhaps it means its running style was a bit different, or its usual habitat didn't demand that kind of extreme adaptation. It's one of those details that makes you think about its specific lifestyle.
Fascinating. Any other cool skeletal features?
Oh yeah, its neck vertebrae, the cervicals were highly pneumatized.
Pneumatized, meaning they had air spaces inside. Like birds.
Exactly. Complex internal air chambers within the bone itself. This is really strong evidence for cervical air sacs, part of a sophisticated bird-like respiratory system.
Lighter bones, more efficient breathing.
Precisely. We also see some signs of this pneumacity, these air spaces, in the vertebrae at the front of the back and in the tail. But interestingly, not in the sacral vertebrae, the ones fused to the hips.
So not quite the full-blown pneumatic system of modern birds, but definitely heading in that direction.
Definitely shows those connections. And one more little thing about the feet. Remember those foot bones Smith and Galton designated as the lectotype?
Yeah.
Well, a study back in 2001 looked at a whole bunch of Archaeornithomimus foot bones, 229 of them, specifically looking for stress fractures.
Like the kind athletes get from repeated impact.
Exactly, and they found none. No signs of stress fractures in any of those 229 bones.
Wow. What does that tell us? Maybe it wasn't running itself ragged constantly, or had really tough bones.
Could be either, or both. It's intriguing, right? It raises questions about its typical activity levels, the kind of terrain it favored. Did it avoid really high-impact running most of the time? We don't know for sure, but it's another clue.
Okay, so we have this feathered, beaked, medium-sized runner with air sacs in its neck. Where does it actually fit in the big dinosaur family tree? Russell originally put it in Ornithomimidae, right? The main ostrich mimic family.
He did, yes. And for a long time, that's where it stayed in most classifications.
And things have changed with cladistics and all that.
Things have gotten, well, more nuanced. As we use these cladistic analyses, basically, computer programs that map evolutionary relationships based on shared features, the picture for Archaeornithomimus has wobbled a bit.
How so?
Some recent analyses still place it within Ornithomimidae, as Russell suggested, but others actually position it more basally within the larger group, Ornithomimosauri.
Basally meaning, like on an earlier branch, closer to the common ancestor of all Ornithomimosaurs.
Exactly. Sort of like an earlier offshoot, before the main Ornithomimidae family really diversified.
And wasn't there that link to Archaeosaurus you mentioned earlier, from North America?
Ah, yes. That comes from a specific, very large phylogenetic analysis done in 2019 when they were describing another dinosaur called Hesperornithoids. This analysis, sometimes called the Lorry matrix, actually found Archaeornithomimus nested within a different family altogether, the Garudimimidae.
Garudimimidae. Okay, who else is in that family?
The namesake Garudimus, also from Asia, and Archaeosaurus from North America.
So that analysis suggests Archaeornithomimus is actually more closely related to Archaeosaurus than it is to, say, Ornithomimus or Struthiomimus.
According to that specific study, yes, it puts it in a different branch of the Ornithomimosaur tree. We even have a cladogram showing that placement, putting it alongside Archaeosaurus and Garudimus, separate from the main Ornithomimidae group that includes things like Ornithomimus itself.
Wow, so its exact position is still a bit debated depending on which analysis you look at. Basal Ornithomimosaur, true ornithomimid, or maybe a Garudimimid.
Precisely. It really highlights that phylogenetic placement can sometimes shift as we analyze different data sets or use different methods. It's not set in stone.
Science in action. Okay, let's shift from the who's related to who to the where did it live and what did it do. The Iron Debossu Formation, what was that place like 96 million years ago?
Right, the paleoecology. So during the Cenomanian stage, when Archaeornithomimus was around, the Iron Debossu area seems to have been a pretty dynamic environment. Think large floodplain terrains.
Lots of rivers.
Yeah, braided rivers, meandering streams, the works. And importantly, evidence suggests these river systems were connected to the ocean. So maybe a coastal plain or large delta system.
Sounds potentially lush then, wet.
Very likely. We find evidence in the ancient soils, paleosols, and also just the sheer number of herbivorous dinosaur fossils found there, things like hadrosauroids.
The duck-billed dinosaurs.
Those are the ones. Their presence suggests there was plenty of vegetation around to support them, which in turn would support other parts of the food web.
Okay, so what was Archaeornithomimus eating in this environment? We talked about the beak.
Right, that beak points towards omnivory, much like its relatives. It was likely pretty opportunistic.
Eating what? Plants? Bugs?
Probably a mix. Small mammals, if it could catch them, definitely plants, maybe
Wow.
fruits, seeds, tough vegetation, insects, eggs, maybe even hatchlings of other dinosaurs if it got the chance. That beak would have been a versatile tool.
A sort of prehistoric generalist feeder. Not too picky.
Probably a good strategy in that kind of environment.
And who else was living there? You mentioned hadrosauroids.
Yeah.
Any big predators? Other interesting dinos?
Oh yeah, the Archaeornithomimus fauna is pretty impressive. On the theropod side, the meat eaters, you had things like Electrosaurus, which was a medium-sized tyrannosauroid,
A relative of T-Rex?
a distant relative, yes. Then there was Erlionsaurus, a therizinosaur, those weird theropods with big claws, possibly feathered. The truly enormous Oviraptorosaur, Gigantoraptor.
Gigantoraptor. That thing was huge, right?
Absolutely massive for an Oviraptorosaur. And another odd therizinosaur called Nemongosaurus. So lots of different theropods sharing the space.
And plant eaters besides the duckbills.
Yep. You had Bactrosaurus, which is a hadrosauroid, Gilmoriosaurus, an iguanodontian-type dinosaur, and even sauropods, the long-necked giants represented by Sonatosaurus.
Wow, that's quite a neighbor's list. That restoration image showing Archaeornithomimus with Gigantoraptor and Electrosaurus really puts it in context.
It does, doesn't it? It helps you visualize. This wasn't just one dinosaur wandering around. It was part of a complex, thriving ecosystem.
A busy place, the Iron Debasu floodplain.
Definitely seems like it was.
Okay, so let's try and wrap this up. We've gone from the name to the bones to the ecosystem. What are the big takeaways about Archaeornithomimus?
Well, I think first that name itself, ancient bird mimic, really sets the stage. It reflects how long we've been puzzling over these bird-dinosaur connections. Then there's the journey of its classification from Ornithomimus to its own genus and the ongoing debate about its precise spot on the family tree.
Right, and the physical picture. Medium-sized, feathered, beaked.
Running around those late Cretaceous floodplains in Inner Mongolia about 96 million years ago, probably eating a bit of everything, and sharing its world with giants like Gigantoraptor and early tyrannosaurs like Electrosaurus.
And I think for you listening, the story of Archaeornithomimus is such a great example of how science actually works. It's not static, it's this ongoing process, new finds, new analyses. They constantly refine the picture.
Exactly. That's the aha moment, seeing how these scattered clues, the fossils, the geology, the anatomy, all slowly build up into a more complete, though never totally final, understanding of the past.
Each discovery adds another piece to that giant prehistoric puzzle.
Couldn't have said it better myself.
So here's something to chew on, a final thought. Given what we know, its bird-like features, that likely omnivorous diet, how might Archaeornithomimus's actual behavior have mirrored some of the flightless birds we see today? Think about ostriches or emus. Could it have lived in groups, had similar foraging strategies, maybe even similar mating displays? And what might future discoveries, maybe even exceptionally preserved fossils, tell us about its social life, how it raised its young, or even what color its feathers were?
Great questions. It just reminds us that even after centuries since its discovery, the story of this ancient bird mimic is definitely not finished. There's always more to learn.